Okay, here's a quick recap of the homeostasis test paper. So question 1 asks us to look at this graph and calculate the difference in blood glucose concentration between person A and B at 90 minutes. So we can see here's 90 minutes, person B is a glucose concentration of 5, person B is a glucose concentration of 12, and so 12 minus 5 gives us an answer of 7 here. We're then asked to use information from the graph to describe the change in blood glucose concentration for person B during this 2-hour period. Person B here is important, there's no point talking about person A. So let's have a look at the graph then. So what we need to say about their blood glucose concentration is it initially rises up to the 60-minute mark, so it's increased steadily so far. It then it rises from 5 to 6.2 or thereabouts. It then decreases from 60 minutes to 90 minutes, so that's the next half hour. Then it decreases from about 6.2 to 5, and then it increases ever so slightly up to 120 minutes. And if we say all that, it'll get us 2 marks. It then says, state which hormone a type 1 diabetic such as person A would use to control their blood glucose concentration. The 2 hormones we've learned about for blood glucose control are glucagon and insulin. And if you're type 1 diabetic, you don't produce any insulin, and so insulin is the correct answer here. We're then asked to complete the sentence by putting a cross in the box next to the correct answer, and excess glucose is converted into glycogen, and it's in the liver, although it's easy to get confused because the hormone glucagon is released from the pancreas. So it's hormones made in the pancreas, but the conversion of glucose to glycogen takes place in the liver. I think I said that wrong actually, so we're converting glucose to glycogen, and so it's insulin, the hormone, sorry, not glucagon. Okay, let's turn over then. Let's get a blank one. Okay, it says type 2 diabetics also have problems with blood glucose regulation. Explain how type 2 diabetics control their blood glucose concentration. Well, if you're a type 2 diabetic, you do make insulin, but it's become ineffective because the body has become resistant to it. And type 2 diabetics, they control their blood glucose by using a combination of controlled diet and exercise, and it's 1 mark for each of those. Moving on as quick as we can then, question 2 asks us to look at this graph comparing body mass and the percentage of the population that to have these body masses, and that's split into people with type 2 diabetes and people with a mean body mass. So as we can see, what actually happens is that as the mean body mass increases, which is the line with the triangles, that increases fairly steadily, we can see the percentage of the population with type 2 diabetes also increases. So it's a complicated graph, and for the diamonds we need to look on the left hand scale, and for the mean body mass we need to look on the right hand scale. A complicated graph. But the question asks us to use information from the graph to describe the correlation between type 2 and body mass, and all we need to say that is that as the body mass increases, then generally the incidence of type 2 diabetes also increases because the percentage of the population with that goes up. Quite tricky to see because that graph is fairly unusual. And then finally asks us to suggest how a change in body mass may cause a person to develop type 2 diabetes. For this one, we simply need to say that if body mass goes up, then a person becomes overweight or obese, and that's linked to an increase in type 2 diabetes. Okay, so we're now on to a question with a bit of maths. It asks us to calculate the BMI for a person with a mass of 78 kilograms and a height of 1.7 meters. So we need a calculator for this. So it's going to be, if we look at the equation, mass divided by height in meters squared. So I'm going to do 78, which is their mass, divided by their height squared, 1.7 squared, and I've put that in a bracket to make sure the calculator does it the right way around, and it gives an answer of 26.98, but we can round that up to 27. 2 marks for that one. We've now got a graph of body mass index for this person, and we need to decide whether they're overweight, underweight, normal or obese. So let's have a look then. So mass of 78 kilograms, so we're going to look across here, 78 is somewhere there. Height of 1.7 meters, so you can see they are firmly in the middle of the overweight band. So it's going to be answer C for that one. Okay, the question now asks us to describe how the body acts in response to low glucose levels in the blood. In the test that my class did, that's 10 to L, lots of students got confused here. All we need to say is what the body does to reduce the glucose level back to normal. And so what we needed to say was insulin is released by the pancreas. The insulin converts glucose to glycogen, which is then stored in the liver. And that's 3 marks. Okay, so we now have a question looking at the pattern of control of body temperature in the body. So you can see we've got a body temperature of 37 with blood temperature rising and then coming back down again, and then the opposite happening here, blood temperature lowering and then rising back up again. To complete the sentence, the type of control shown in the diagram, the only type of control we've talked about in lessons is negative feedback, so that should be answer A. It then asks you to state the part of the brain that controls body temperature, and it's just something you have to remember here. It is the hypothalamus, which is the part of the brain just there. Okay, we've got a 6-mark question now, always a tricky question to get 4 marks. It says in the UK the external temperature can drop below 0 degrees C. Explain how the human body maintains a stable internal temperature when the external temperature is 0. So if the temperature of the body is 37, but it's in an area where the outside temperature is 0, then the body has to work quite hard to maintain that temperature, and it does it in these ways. So you can start off by saying that the hypothalamus detects a drop in temperature, and one of the first things it's probably likely to do is to make the hairs on your body stand on end. They trap a layer of air which insulate the body and help to keep it warm. The other thing that happens is the blood vessels near the surface of the skin close, and we want to try and use the keyword vasoconstriction. That stops blood flowing near the surface, which can cool down because of the cold outside temperature, and helps maintain the body's core temperature nice and warm at 37 degrees. We could also say that the body starts to shiver, and that shivering moves the muscles and helps to generate some heat to help keep the body warm. And if we can mention those 3 things in that much detail, then that's 6 marks easily. Okay, moving on as quick as we can. On to the last page. It says the temperature of Rebecca's brain and of one of her fingers was recorded at 6 different external temperatures. Calculate the maximum range for Rebecca's finger. Again, my class that did this test, they really struggle with this question, and range means biggest value minus smallest value. So I'll get the calculator again, and we'll look in the list here. We can see that for the finger, the biggest value is 37 degrees, and the smallest value is 34.3 degrees, and so it's as simple as 37 minus 34.3, and that gives the range at 2.7, biggest minus smallest. Okay, we then asked to compare the temperature of Rebecca's brain and her finger as the external temperature decreased. So, as the external temperature decreases, just pull that down a little bit, we can see that the brain's temperature fluctuates, 36.9, 37, 36.7, 36.8, and so on. It varies, but there's no overall change, so it's 1 mark for saying the brain stays at roughly constant temperature. The second mark requires us to say that as the external temperature reduces, the temperature of Rebecca's finger also reduces, and that's quite a steady reduction. Interestingly, in the question here, we've got a command word that says compare, and we don't need to do any explaining for this, we just need to compare those 2 temperature ranges. Now comes the bit where we need to do some explaining. So it says, explain why the temperature of Rebecca's finger showed this response to the decrease in the external temperature. So what we're looking to say here is why the brain stayed at a constant temperature but the finger didn't. And the sort of things we want to say are that the brain has a steady flow of blood, and that steady flow of blood maintains its temperature at 37 degrees. The finger is a more exposed part of the body. Vasoconstriction takes place in the finger, blood flow is reduced to the surface of the finger to reduce heat loss to the surroundings, and so the temperature of the finger decreases. And then the final part of the paper, explain how the body responds to an external temperature of 40 degrees C. Well, we should remember that 40 is above the body's normal temperature of 37 degrees, and so the body's going to have to work to avoid getting too hot. So it's a bit like the opposite of the question we were asked earlier. We need to say that the brain, again, the hypothalamus, detects that increase in temperature, and it does the following things to try and cool down. The hairs stay flat. That doesn't trap a layer of air and helps the body to stay cool. We can say that the body starts to sweat, and that sweat makes the skin wet and it actually cools the body down, because the body then dries that sweat out, it evaporates that sweat, and evaporation is a very effective method of cooling down. And then we can say that vasodilation happens, the blood vessels get wider near the surface of the skin, and that enables blood to flow near the surface so that the heat of the blood can be rejected to the air around the body, and again that helps keep the body down to its normal temperature of 37 degrees. That was 10 minutes and 20 seconds, not bad for a 38 mile test.